Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on September 30th, 2025, about 2 days ago. The striking result is that memorization in diffusion image models stems from early overestimation, caused by classifier-free guidance that injects too much training image content right at the start. The paper is titled, How Diffusion Models Memorize, and the implications for model training are quite significant. In brief, the authors show that this mechanism raises early training loss, collapses diversity across denoising paths, drives near-deterministic copies, and suggests that reshaping the earliest denoising steps can meaningfully reduce copying. The introduction stressed early overestimation as the key driver of copying. Figure 1 shows scatter plots of squared L2 distance versus cosine similarity between the predicted clean image and the training image across denoising steps. The top row without strong guidance clusters at lower error, while the bottom row with guidance of about 7.5 shifts left panels toward larger early errors. Left column panels highlight that first steps already push predictions toward the training image, which raises similarity even as error increases. So Figure 1 showed that guidance raised early errors while nudging predictions toward the target. Figure 4 shows two rows that make this concrete. The top row lists training images, and the bottom row shows their first step predictions under guidance of about 7.5. The first denoising step already resembles the targets, which signals strong injection of training content. This visual jump illustrates early overestimation that suppresses randomness and anchors trajectories toward memorized copies. So Figure 3 links that first step injection to outcomes. Figure 3 shows SSCD scores with guidance on the vertical axis versus without guidance on the horizontal axis, with a dashed red diagonal marking no change. Most points sit above the diagonal, which means guidance increased memorization for the same prompts. A dense band touches the top edge, showing many prompts saturate near full copying. The pattern holds across the range of unguided scores, so the effect is broad rather than isolated. Alright, the previous figure tied guidance to higher copying. Figure 5 now measures cosine similarity at the first step, comparing noise predictions with the initial latent XT and with the training image. Panels A and B sit near 1 with XT, which means both unconditional and conditional predictions mainly echo the starting noise. Panel C hovers near 0 against negative X, while panel D rises strongly under memorized prompts, showing conditional predictions carry training image information. Okay, Figure 6 turns that finding into geometry. The figure shows how the guidance scale combines unconditional and conditional predictions to set the first step estimate, which points toward the training image with a magnitude that scales with G. Panel A shows G equals 0.5, so the green arrow lands near half X. Panel B shows G equals 1, which lands almost exactly on X. Panel C shows G equals 2, doubling X and clearly demonstrating overestimation. Alright, the previous figure established how guidance scales the early push toward the target. Figure 10 shows a decomposition of each intermediate latent into a clean image part and an initial noise part, with theoretical schedules drawn for reference. The top row with guidance near 1 tracks theory for normal prompts, while the memorized panel already boosts the clean component and suppresses noise. The bottom row with guidance around 7.5 exaggerates this. Memorized prompts overshoot blue early and drive red down fast, which signals excessive injection and rapid convergence. So the previous figure highlighted aggressive early injection. Table 1 summarizes prompt categories and counts across Stable Diffusion v1.4, v2.1, and Realistic Vision, with fractions showing how many prompts had retrievable training images. The totals were about 436 of 500, 389 of 500, and 435 of 500, respectively. Categories include matching verbatim, template duplicate, retrieved verbatim, and none, which distinguish exact copies from looser template reuse. The authors later rescored prompts using SSCD because some original labels and links proved unreliable. Wrapping up, two takeaways stand out. Early overestimation under classifier-free guidance injects too much training content at the first steps, and that surge collapses diversity, steering trajectories toward near copies. The broader implication is practical. Tune or taper guidance during early denoising to cut copying and improve safety. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.